So unit analysis, or sometimes called dimensional analysis, is one of the most useful strategies that I'm going to teach you. It's something that you can use in your science classes, you can use in your real life, right? It's just a super handy thing to do. So what it does, what I mean, right, when I say unit analysis, is it lets us calculate between different unit systems. So we can convert between different unit systems. It also is super helpful if you're doing some dosage calculations. And the way it kind of works is that we're going to use these units as almost as a variable so that we can cancel common units. There's one on the top of a fraction and one on the bottom of a fraction. So let's go ahead and take a look at it, and I'll show you what we mean. So again, basic ideas: if two quantities have the same value but can be represented by different numbers, so we make a fraction of those two numbers. Since they represent the same thing, that fraction is equivalent to 1. It's not going to look like 1, but we're just going to keep reminding ourselves that, oh yeah, they're really talking about the same thing, top and bottom. Okay, so we multiply by 1. It doesn't change the amount. That's how we change between units. Okay, so our first one here, we're going to convert 72 hours into days. So I need a conversion. I need something. I need to know how many hours are in one day. I need some kind of relationship between hours and days. So, right, some of these we're just going to know. Some of them I looked up. And I just wrote days. So 24 hours equals 1 day. Right? So those two are equivalent. That means I can make a fraction and it's equal to 1. So I could either say 24 hours over 1 day, or I could say 1 day over 24 hours. Now you have to put the units on or it's not going to make sense. Okay, so these two, right, since they're marking off the same amount of time, these are equal to 1. So when I think about my 72 hours, so that's where I'm starting. I have 72 hours and I want to know how many days. So I'm going to take my 72 hours and I'm going to multiply it by either 24 hours over 1 day or 1 day over 24 hours. And I want to pick the one that will let me cancel this hours and leave behind days. So I'm going to choose the second one. So if I multiply that by 1 day over 24 hours, then I have an hours on the top of a fraction and hours on the bottom. I can cancel those. And the unit I'm left with up here where I want it is a day. So put a 1 under your 72, multiply across. So I have 72 over 24 days. And you can either grab a calculator, do some long division, do some reducing. Turns out that that is 3 days. Okay, so let's do another one. 2.5 hours into minutes. So we're going to start with what we know, what we're given, that 2.5 hours. And I need to get that into minutes. So think about what the equivalencies is. So 1 hour is 60 minutes. Hours is the thing I want to cancel. So these two are the same. So I'm going to put 1 hour in the bottom, 60 minutes in the top. The hours can cancel. I'm left with minutes, which I wanted. Not feeling like I want to do that arithmetic. So 2.5 times 60, 150 minutes. Okay, it's super important that you keep writing your units down. So 3 miles into feet. So write down what you're starting with. So 3 miles. Right, we know we're going to need that 1, so we'll go ahead and do that. Then I need the relationship between miles and feet. So let's see, it's 1 mile equals 5280 feet. So think about who's going to go in the bottom. Miles is on top, and that's what I need to cancel to get to feet. So I'm going to put the 1 mile on the bottom. The 5280 feet on the top, cancel your miles, one on top, one on bottom, and then multiply across. So 3 times 5280, 15,840 feet. Okay. So this next one, we have a couple of conversions to do. I have 60 miles per hour. So the per, what that does is, right, that makes an actual fraction of the unit. So I have 60 miles per 1 hour. Okay. Oh, this is going to be a long train. I might need an extra piece of paper to get to the end of this one. So I need to get from, what I want to go from is miles per hour into feet per second. Okay, here we go. So I need to get from miles to feet, and I just showed you what that one is. So 1 mile, I'll put that on the bottom. So those will cancel. And 5280 feet on the top. So I'm going to go ahead and cancel my miles now because I know those are gone. So now I know feet per hour, but I want feet per second. So I need to get rid of hours and get to seconds. So 1 hour is 60 minutes, so I can do that part. So I'll put 1 hour on top so that the hours cancel. 60 minutes on the bottom. So that'll give me, cancel your hours. So now I'm at feet per minute, but I want feet per second. So here we go. 1 minute on top, so that'll cancel that minute on bottom, is 60 seconds. So go ahead and cancel your minutes. And now I have the units I wanted, feet per second. So now I'm going to multiply across, divide at the end. I might actually cancel out a 60 here and here just so that I don't have to do that. And it looks like I just have a bunch of ones and 5280. So 5280 feet on top divided by 60 seconds on the bottom, 88 feet per second. Okay. 1/4 cup into ounces. Okay. So I have 1/4 cup is on top. So now I need to know a relationship between cups and ounces. And you can look these up. It's 1 cup is 8 ounces. And the abbreviation for ounces is OZ. It's odd. So the cup goes on bottom, so I can cancel. 1 cup, 8 ounces. Cups cancel. Left with ounces. And I have 1 times 8, and the 4 is in the bottom, so I'm going to have 8/4 or 2. So 1/4 cup is 2 ounces. Okay. 3 gallons into ounces. Well, there are 16 cups in 1 gallon. So I'm going to put 1 gallon on the bottom, 16 cups on top, right? If they're measuring out the same amount, that means the ratio of them is equal to 1. Doesn't look like 1, but remember, 16 cups is the exact same thing as 1 gallon, so this is 1. Gallons cancel, so now I know how many cups I have. I want to get to ounces. 1 cup is 8 ounces, so how do you think I'm going to write that fraction? Who goes on top, who goes on bottom? Right, so I want the 1 cup on bottom so it can cancel. 8 ounces on top to get to the units I want. And then I'm going to multiply across. So 3 times 16 times 8 is 384. Denominators are all 1, so I don't need that. And the units that were left were the ones I wanted. Ounces. 5 kilometers into miles. Okay, this one might take a bit again. So a kilometer, so I have 5 kilometers. Let's see, 1 meter is 3.28 feet. There are a bunch of different ways you could set this one up depending on what conversions you might happen to know. Oh, let's see. And then 1 kilometer is 1,000 meters. So let's go ahead. Oh dear, this might be a little bit too long. I should have looked up a different conversion. That's okay, we can do it. So 1 kilometer, let's get that into meters first. So 1 kilometer is 1,000 meters. And then I can get to feet. So I'll do 1 meter on bottom and 3.28 feet on top. So let's see, kilometers get to cancel, meters get to cancel. So now I know how many feet, but I wanted miles. So now I need the conversion between miles and feet. So it is 5280 to 1, but the 5280 feet is going to go on the bottom. And the 1 mile on top to get the units that I wanted. Sorry, that's getting a little cluttered in there. But I can cancel my feet. Everybody's canceled. I'm left with miles. So let's see, I have 5 times 1,000 times 3.28 for the top. And then we're dividing by 5280. Here we go. Let's see if you can see that. So 5 times 1,000 times 3.28. Divide 5280. So 3.1. So 3.1 miles. So if anybody's a runner out there, you probably already knew that, right? If you run a 5K, that's about 3.1 miles. Okay, 1 liter into milliliters. I'm going to grab, sorry, I'm going to switch to my, oh, here we go. I've got a black pen. My pencil's about done there. So 1 liter into milliliters. So there are 1,000 milliliters in 1 liter. So we're going to start with 1 liter, and I want to get to milliliters. Okay, so I'm going to put the 1 liter on bottom and the 1,000 milliliters on top. Those guys cancel. 1 times, oh, it's just 1,000. Hey, that is right there. 1,000 milliliters are in 1 liter. Okay. Now, if you have like a map or some blueprints, right, that you're using, a lot of times there's going to be some sort of conversion scale written someplace on the map. So let's go ahead and look at this first example. So this is going to be the map example. So if the scale is 1 inch on the map corresponds to 20 miles on the road, let's find the following. So right there's our, 1 inch. So 1 inch on the map is 20 miles on the road. That's the fraction we're going to use to make. Okay, so I have a map. It says 7.5 inches. How many miles is that on the road? And we're assuming that, right, it's all kind of straight-ish. So when I do that, I'm going to put that 1 inch on the bottom and the 20 miles on the top so that the inches can cancel. So I need 7.5 times 20. I just have my calculator over here doing that. So 150. So 150 miles for that 7.5 inches on the map. Okay. Now, if you know that it's 200 miles, how many inches will that be on the map? Right, so this time I'm going to put the 20 miles on the bottom so that I can cancel those and know how many inches that is. That looks like lynches. That's a 1. 1 inch. Okay, so the miles cancel. 200 times 1 divided by 20. 200 over 20. I guess I'm doing this the long way. 2 looks like 10. So 10 inches. Okay. And then on blueprints, so this actually happened to us. We were looking at some blueprints and it said 1/4 inch on the drawing corresponded to 1 foot of cabin. Okay, of actual like space in the cabin. So here we go. The blueprint, it measured 7.3 inches. How long was that in the cabin? Right, so my unit is, right, I'm going to do a decimal if that's okay. So 0.25 inches on the drawing equals 1 foot in the cabin. Now you have to be careful. We're not doing the 12 inches to 1 foot thing here, right? This is the conversion when I'm going between my blueprint and my building. Okay? So my blueprint is 7.3 inches. Okay? My conversion, so I have 0.25 inches goes in the bottom so I can cancel. And that will tell me how many feet of cabin I get. So that's going to be 7.3 divided by 0.25. 7.3 divided by 0.25. So 29.2 feet. Okay, so almost, right, a little over a 29-foot wall is what corresponds if you have 7.3 inches on your blueprints, okay? So going the other way, oh, if I only have 8 inches on the cabin, well, that's not very much at all. This is going to be a really small number. How far is that going to be on the blueprint? So the cabin, so this is 8 inches of cabin. Oh dear. I'm not going to be happy about this. I'm just going to tell you. So that actually goes with the foot. So that's going to correspond to, I am so sorry, this is a terrible example. In fact, we're going to change it. We're changing it on the fly. Here we go. We're going to say 8 feet of cabin, just so that we're not confusing you on something like this. So that's going to be 8 feet of cabin. How many inches is that on the blueprint? Okay, so I'm going to put the 1 foot of cabin on the bottom, the 0.25 inches of blueprint on the top. So now I can cancel the feet and the feet. I have 8 times 0.25. And that is 2 inches. Make sure I get the right units there on the blueprint. Okay, last example here. Here's a chemistry example. So aluminum has a density of 2.70 grams per milliliter. What is the mass? That's the grams part. That's the G. What is the mass of a cylinder of aluminum with a volume of 3 milliliters? So if you just look at your units, so the things that I have are 2.70 grams per milliliter. I also know that I have a volume of 3 milliliters and I want grams. So can you see that if the operation I choose is multiply 3 milliliters, I'll stick a 1 under it so that it looks like I can see the milliliters canceling there. Right, I have a milliliters on bottom, a milliliters on top. The thing I get left with is grams, which is what I wanted. Okay, so I can kind of use the unit analysis to do a little reverse engineering to see the answer or the operation I should choose to get to the units of the answer I want. So 2.7 times 3. 8.1 grams.